Hello, thanks for checking out Integrator software. My name is Oleg Garipov, I am a CTO of this company and I like making databases available to people visually as big pictures, which are also completely active, to allow better analysis, integration and evolution of data. Integrator can connect to existing databases and unify the data. In this example, phone call information is held in 4 legacy databases from 2 different vendors. The data reverse function of Integrator queries these databases for their structure and their data automatically to provide the information needed to access them. Once the datasets are joined in Integrator format, searches are performed across the combined datasets. On a Sybase server, there is an AT&T database of phone calls. Enter URL, login and password, click Retrieve. You will see 2 tables, one call time and duration data, the other with sound quality data. Phone number format has 1 in it, followed by area code and other numbers. And records on 2 tables describe the same calls. They are connected by values of ID and by time. Then there is another database server, Postgres, with Sprint database, with 2 tables with phone calls separated into bins by record age. One with current year's data, the other with data for a past year. Phone number is separated into 3 columns, area code, group and extension. Sound quality is suggested by noisy indicator. Because the databases are from different vendors, database metadata will be in different structures. On Sybase and Microsoft SQL Server, we will see the following metadata tables. On Postgres server, they will have slightly different names and conventions. Vendor-specific metadata is automatically decoded and table structures resolved into a convenient integrator structure with column labels to prepare for further integration. These depictions are the entity relationship diagram. We now design a graphical interface in Integrator to the data in these tables. Label value pairs are entered in natural language terms and real data is entered in the desired format. The user creates this example of a data object which will incorporate the data from the target databases simply by clicking New Container and calling it the call. They then click and populate 5 label value pairs. As the central data model is created, Integrator automatically creates hierarchical metadata with a master label object for the container and label objects for each text value. The manual tasks to perform on this reversed data from the many data sources are shown next. First, each label of the central data model on the left is mapped onto the target database columns on the right. Then the user enters the mapping SQL to transform data to unified form in the field in the master label object. In this example, the phone numbers in Sybase are preceded with a 1 and have no dashes. The 2 tables are joined by their unique IDs to assemble a complete object in Sybase. In the table ATT call, the phone number is reformatted and taken as is from the table ATT call ENG. Unless one can see the data, these format differences would not be noticed. The complete Postgres mapping is done in the same way and in the same master label object of the common data format. The common data format is used for the search. The search command provides a blank form with all the objects and their names. This form is then populated to specify a query by any attribute of data model as a snippet of SQL. For example, find calls from callers with numbers beginning with 2, enter a couple of specified numbers receiving the calls, and specify conversations lasting more than a minute. The query will run against all databases and combine the results, although still clearly showing the source database for each record. So this is a combined search result executed in real time and unifying the data from disparate sources. For unstructured data, values can be stored as text to allow search. Our conversion algorithm will parse unstructured data, such as a PDF file, find parts within it, and assign fine-grained values automatically, along with their location. Instead of live queries to each of the source databases, a fast embedded database, such as BangDB, can be used to hold data from all sources to speed up the queries. In this example, a BangDB wide table is created and loaded with JSON objects in integrated data model. B-tree indices are created on fields color and sound quality. They enable scan document searches returning JSON results, which are automatically shown as a simple grid in integrated data model. Java implementation using BangDB APIs is shown here. It opens the database, creates a white table, creates indices, puts documents, scans for documents, and displays the results. A look under the hood. Here is how the implementation algorithm generates SQL from the search form snippets and the data-specific SQL stored on the label objects, and then runs all queries. In this Dracon depiction of the search routine and subroutines, each box has its task shown in natural language, but the corresponding line of code in Java is stored on the same object and used to assemble an executable file at runtime. The following SQL search queries will be created automatically from the snippets in the search form and run by the algorithm. Thank you for your attention. We welcome your feedback and would like to hear from you.